Hello, so my name is Kunal, and it's not only me who have contributed on this. There are a lot of other guys. Uh, there was my colleague was also about to hear, but unfortunately he was not able to make it. So I'm presenting it, and yeah. So it's not only the engineers who has experience, but also from college they have contributed towards development of this. And as we have already heard about VUnit. I will try to focus on the area where VUnit has actually powered us to develop something really interesting in terms of mathematical functions. We have already talked about VUnit verifying the signal level activity. This will give you some overview of how VUnit is helping us to make sure that the mathematical functions which we are developing are holding tight. Yeah, so today's agenda will be like I will introduce something on mathematical functions, MathLib. We go into little bit like what is MathLib and why, and then we jump into the verification part where VUnit has actually helped us, and then we go into Q&A sessions. Okay, so I think this slide holds true and everyone knows about this. Today's world is more about precise computations. You need to be more and more precise in terms of your calculations in order to have the end application correctly fit in the today's world or the complexity of the world applications. So it just shows how much it is important to have everything right in first place. So if you talk about modern chips, whether ASIC, FPGA or systems, it has to be, they are the confluence of many things: analog, digital, statistics, AI, which is a new buzzword, some probabilities and other things. And it is really important that when a particular system has been designed by the architects, they do have some reference in their mind as a reference models. And then once that proof of concept is done from architecture level, it boils down to the implementation part where we go into the design and verification. You all know, once it is in hardware and if we have bugs, we are screwed. We are talking about millions and maybe billions. So we cannot live with that. And that's why I think it is important that every single part or every smaller part of your design has to be tested. And you know, today's license and tools, they are very hefty in terms of cost. If you do not have right debug capabilities, your productivity will reduce and it will bite you back after some time. So this is just an overview of where we are going. Right. So MathLib is nothing but we are targeting the mathematical functions which we may already have with MATLAB or someone wish to have in the open market. So it's nothing but an open source where we try to target the AMS domain where we have ADC, DAC, LDO, VC, all those functions, coefficient related mathematical functions where you do complex calculations with the basic functions. You have square root, round, floor, ceiling. There are a lot of things, but it's not simple as you can think of when you go into the real verification or design world. Even the ceiling or rounding or mean square values does not hold true as it is when one architect had taught during the systemization time versus when it has been really implemented on the signal level. They both are sitting at a separate world. Another usage which we have actually used is in biomedical. There are the student name which I have just gave. They are working on this glucose monitoring strips where you need a very precise calculations. We have also trying to fit in MATLib with the fintech where you have high probability of AI activity on the share markets, how the shares will go up and down. So it's also one of the applications that some people are trying to invest in. and then of course the statistical functions. I have put MATLAB here in the last line. You see, we are not trying to match the exact mathematical output or very very precise combination in terms of mathematical work, but we are trying to match with the MATLAB, and I will show you the reason why I'm saying MATLAB. Yes. So if you see, what is MATLAB? Why MATLAB? First of all, today there is something lacking in terms of one-to-one mapping when we move from MATLAB or a reference model world or modeling world towards the actual implementation world. Say it SV or UVM, because that's the design we use. And when I say closed functions, it may not be exactly matching, but we are trying to solve this space with an open source library where people can use it as it is, and they can have compatibility along with the MATLAB functions. And the intention here is that they should match with the system level applications. They may not be like full set of MATLAB functions, but can be application specific. Like if you are targeting AMS, then MATLAB version of AMS will provide you all the functions that are required only in AMS, biomedical or algorithm execution. But you do not have all in one set. So we are still in the development phase. We have not addressed all the functions of MATLAB, but application specific functions. And today, if I go to any company, an architect will try to design their system based on some model. And today, MATLAB has been widely used as a model. Now, when I say MATLAB, so when an architect designs something, they will come up with a value, let's say 3.666 up to 10 digits. But when you try to replicate it in the real mathematical function, it can be up to 100 digits, 3.66 up to 100 digits. Now, those last 6 digits or 10 digits versus 100 digits in decimal may not be very significant when we talk about it, but it will tend to accumulate over a period of time. So I will go to that in my next slides, like how it can accumulate. But I think it is important to know that the way design has been systemized initially has to be implemented when it goes to the real field. Yeah, and we are trying to do it in both System Verilog and VHDL. System Verilog is already there in the MATLAB. VHDL we are still doing it. It hasn't been rolled out, but we hope to do it soon. Okay, now things get a little bit more detail oriented or more fun for technical guy like me. So here if you see, I have showcased the floor function or exponential function. And you see this, as I said that we are done with the System Verilog package, we are using module class and interface. So we need to call something from them into the MATLAB. So we do have a MATLAB function, but here you see we are using System Verilog floor function or the exponential function for ME raised to or 2 stars NU. So it's equivalent to System Verilog function. And if we try to model it in or try to match the architect's output, will it match or not? That was the question that we had previously. Similarly, today MATLAB provides various arguments, including integer, real, vectors, scalar, quantity. So we also try to match them, and an important thing is the matrix part. So today, MATLAB do provide that matrix function, and it is really useful for all the mathematical use. So we do that in the System Verilog using 2D arrays and parameterized classes and everything. So we try to mimic the exact functions which MATLAB have, but may not be necessarily in the same format, but in a different form. Right. So when we developed this MATLAB, so we had very big question like, can we simply write those functions and leave it with, how can we verify? Because for this, you actually do not need any signal level activity. You don't need to understand what is going on, you just need an output. And the most important thing to do this is, it has to be really simple and quick. You cannot go on building more and more complex verification entities. Of course, I am a UVM guy, but I still say UVM is an overkill for this kind of application, where you know the output beforehand, you don't need to keep on building all the things. So we took help from VUnit, which was an open source, and on top of that is based on Python, so we can understand it, we can do it. We use as it is the suits, test case, all the macros, and most important the CI flow which we have, which we get it in between that. Right. So I think my colleague already touched about this, but I'm stressing the point that it supports both system Verilog and VHDL. So we are in a process to do this thing, and the last point here, which I really want to stress, it does not impose any verification methodology. Because now if you go and talk in the verification industry, they always first, or any verification engineer will talk about the methodology, like, okay, what methodology you have, and because you don't need to reinvent the wheel of how things have been verified. And VUnit actually does not need any of those prerequisites in terms of knowledge. You can simply write code as it is. I will show you a snapshot. It's bare minimum requirement to understand and verify things. All right. Now this is really interesting one. If you see the code on the left top, it's pretty simple. What it does, it tries to get the exponential value of 1.5. And you are putting the value 4.4817 as your expectation. Now why is that? Now if you look at the right bottom corner, Matlab gives value 4.4817 of 1.5 exponential. And if you do not use MathLib, or if you use simple system Verilog or any C function, it will tend to give you lot many bigger numbers than 4.417. Now, if your system has been architected expecting the value which is here, and if your real hardware gives you output what is here, I am not sure it will work if it is really complex calculations. And that is why we need something which will actually check these values as a mathematical function and not these values. I know this, I talked about precise computation, but precise in terms of what is expected and not is in the real world. And that is where I think, this is a very simple example of code which I have shown, but it has gone a little bit more complex than that. I'm just showing it here because the scalar value here is only 4 digits in decimal that is expected. We can extract the expected value from different tools, like today we have octet and other things. But again, when you extract the values from other tool, this preciseness will be lost. So it was very dangerous to use other tools, which or even C functions from open source or anywhere else, where it was not matching your actual expectation of your architects. Of course, your architects has to decide which one to use, but today's MATLAB is being used very well by the architects. Right. Okay. So what we have done, okay, this is another interesting thing. So I'm just doing a very simple thing here, modulo operation. And modulo operation can have this many outputs based on how you interpret it. So let's say the output of the mode operation is 0.5, and you see there are actually 5 to 6 possible outputs based on what kind of value you are expecting, like if it is near to even value, near to 0, towards infinity, towards 0, towards minus infinity. And we need to implement such functions or such complexity of a very simple mathematical function. So in our case, values which are coming out were not important, but the number of function operations are important. So we need a very quick and simple solution to test these things. We know the output, we don't want to write extra code, we just like to write 1 or 2 liner code where we can test everything which we have. And if you see, in case even if we miss something, you see that boy thinking about like there are 5 outputs or 5 solutions going out. If we miss something, you will be in the vicious circle. Like you can start anywhere. Like last test, you have not tested all things, then it will be less stable. Your code will be less stable. You will not be accurate. I think that was the motto. You need to be accurate, and then you will feel pressure, and you will keep on rotating that circle. And you see that it is equivalent to something called Lorentz equation or butterfly effect. A minor divergent at the basic function, or like a tenth decimal value or 10-digit decimal value deviation, can lead to a huge butterfly effect in future. So a small preciseness miss may lead to disasters later on, and that is why I think it was very important that we want very simple to solve our verification problem, and I think VUnit has helped us a lot in terms of those writing quick solutions of quick verification statements or checks. These are one of the examples that we have already faced, like in ADC application. Sometimes Matlab model thinks the output was 1, and based on that some decision was taken, and even though we have tried a lot to write a very precise code, the SV model says 0. Similarly, sometimes in low power SOCs or low power application, we have experienced that the expectation was that it should go in powered on, but because it was written in system Verilog or VHDL, the preciseness was missed, and instead of going in powered down mode, it was in normal mode, and the actual application didn't work. Yeah, so it was really nice to fix it at the basic level, at the unit testing with unit with the lowest possible granularity. Yeah, and these are some of the applications that we have actually used. I cannot name all the companies that we are currently using, but they have been using and they are asking for more. This is one of the applications that we see that, okay, we have developed this unit testing and we use the CI flow, and you can see that you can see the output very clearly, like what are the tests which are passing and failing, and you do not need to focus on any infrastructure. Yeah. So I mean, it's not a golden thing that we use VUnit. We do have some looking or forward-looking things required for VUnit also. Education material, I think someone has asked this question, like how do we quickly get ramped up on VUnit? We found it a little bit harder. I think there's not enough awareness, like it does exist, or even if it exists, how can we quickly use it? I think we need something more on top of that, more tutorial, user guides, or maybe presentations. We still feel that we are lagging some debug feature, even though we need very simple verification unit. Still, I think it's good to have some control on the debugging or the log prints. Third, coverage, I think it's the most important thing that we missed, because when we are running these mathematical functions, we actually don't know what values are we covered. Are we covering the corner cases? And especially when multiple people are working from multiple sites, someone from top or someone has to see that if all functions has been covered with how many values, and if there is something missed in the review, it can be easily taken care of. And I think we do not have that in VUnit, especially the system Verilog part. I'm not sure about VHDL. And I think documentation, which most engineers like me hate on top of the technical thing. So I think if VUnit can provide something in terms of dumping out documentation for us, like how it is tested, or what are the things that has been addressed in terms of documentation, I think that will be a really useful feature for the verification community. Yeah, and then we move to summary. I think first to first. So MathLib is an open source. I think you can go in GitHub and just explore. We have used this MathLib for various applications, biomedical chips, AMS. It actually needed very simple verification structure, and I think we adopted VUnit for simple and quick setup. The native code, easy to debug, and the CA flow was cherry on the top. Thank you very much. Questions?
Questions? Yes.
Do you rely on MATLAB for your accuracy?
So it depends on how architects has defined the system. So let's say if system engineers has used MATLAB to develop their mathematical reference model, yes, then if system architects has used pure mathematical functions out of the textbook library, then we need to mimic that. But I think in today's ASIC industry or FPGA world, MATLAB has been used by most of the architecture team. So, yeah.
I can comment on that as well. I discussed it with the MathLib team that, of course, you can use the Python scripting to call MATLAB to actually provide the reference values into it. Or Octave that many use, which is a sort of open source clone of MATLAB. But I guess it's tricky. If the architect uses the MATLAB, can you be sure that Octave will provide the same value? I'm not sure if you can guarantee that.
Yeah.
Either way, Python can call any reference tool and sort of insert the expected value into it.
Yeah, I mean, one of the reason why we cannot use MATLAB is it's expensive.
Yeah.
And many companies at their architecture team has 2 licenses in whole company, and if you want to keep on pulling the license, it will be huge cost. So yeah, that's why it is open source.
Yeah. I also have another comment on the previous slide about, in general, features and information for VUnit. And it's a fact that VUnit was developed as a tool for VHDL developers. And at some point we realized that much of the thing we do in Python doesn't really care about which HDL you're running in the simulator. We use that. So we did kind of the bare minimum to get the system remote test bench up and running, but didn't provide much other than that. Hoping for sort of the community to contribute. It hasn't been much of that, so I'm a bit hoping for Kunal there to make an impact. But generally, I should say about educational material, there are some educational materials which we have hidden quite well, but one of the priorities going forward is actually to make sure that all educational material is open source, very visible, so you won't miss it. It should be possible to do labs, etc. with the unit, just download it as you do with the code. I have some other. Yeah, and of course in VHDL we have, we don't do coverage ourselves, we ship the unit with obviously on third purpose, but that's a difference between VHDL and variable support, how many boxes we can tick on it.
Okay, thank you very much.
Okay.